Hello, this is Industrial Control Circuit Troubleshooting 2 6 module. Now we are doing Genius Skill Test number 6. The work order that we received stated that the agitator is unable to stop. It continuously running until we manually stop it. So what is the problem? Let's dive in. By visually checking the external devices and the circuit, I don't find any problem here so far. Okay, looks like the LED status is fine, no issue. So we had to run the process and see what's happening now. Everything looks like fine, no issue. Okay, agitator is running. Maybe we can check agitator current, 3.2 full ampere. However, the heater is 0 ampere. There's something wrong with the heater. Okay, for 3-phase circuit, we try to measure line to line voltage when the end of the line is not open. Okay, so we can measure to double confirm there is an issue with one of the phase. Okay, 400 volt, 0 volt, there's an open circuit. There's an open circuit. Okay, so maybe we just stop the process and then drain the water. Okay, so for 3-phase circuit, when the line end is open, we can measure the phase voltage. When the line end is not open, then we have to measure line to line voltage. Okay, now the line end is actually open. You look at the contactor button, it's actually popping out, showing it is in the normally open status. Okay, there's a voltage here, there's a voltage here, there's no voltage here. So this fuse is blown, so later need to change. Okay, and then there may be another open circuit in along this 3-phase line up to the heater element. So we had to cut off the power supply to check it and perform the lookout takeout, verify lookout takeout is done properly. Okay, so I want to check the resistance across the device. Okay, just to make sure everything is okay. Before that, I will change this fuse. Okay, then I will measure the resistance across the device. Okay, press this button, the contactor button, to trigger the normal open to close so that we can measure the resistance across the device. Okay, this one okay. This line is okay. Then we measure the line to line resistance. Okay, it looks like everything is alright here. Everything is alright. Okay, $10.7, 10 points, sorry. Alright, so we had to check the heater. Okay, sometimes this open circuit is not due to the open circuit in the wire or the motor winding. It may be due to loose termination. It's best that we check the termination. See, there's a loose termination. That's why it caused this kind of problem. Give you the open circuit. Okay, no more loose termination. And we also measure the resistance across the heater element to make sure everything okay. You see 10.7 ohm, showing that this heater element is not good. It should be around 30 plus. 32 ohm is okay. 32 ohms is okay. So this one we need to change. Okay, then we normalize all the circuit. Okay, normalize everything. Then this one we need to normalize the circuit wiring connection. Okay, make sure everything is normalized. Then we remove the lockout takeout and turn on. Then we can start the process. And maybe we can measure the current one more time to ensure everything is okay. Now we measure the agitator. 3.2 ampere is a full load ampere, full load current, which is the correct one. Now we got the current go through the heater contactor. We also can measure the pump, since we already measured the current for both the agitator and heater contactor. Now awaiting it to reach 70 degree, then it will rest for 5 seconds before it start the pump to pump out the mixture to the next stage. Yes, however 6.3 ampere is very high, far higher than full load ampere or full load current of 2.3 ampere. That means actually the motor must always run on full load current. In this case, for this pump, it should be around 2.3 ampere for full load current. Now it's running on 6.3 ampere, that means it's running on overload current. That means something has happened, overload. The question is, why you ask me, why the overload relay do not trip? The overload relay trip because of electrical overload or single phasing, or mechanical overload may be the pump impeller motor bearing seized, or conveyor belt too tight or too loose, or process overload, maybe the upstream and downstream valve is shut. In this case, it cannot be the electrical overload, because electrical overload obviously it will trip the overload relay. This case can be due to process overload or mechanical overload. Maybe there is something stuck inside the pump. The pump still able to turn, but however not turn in 100% full force. That's why it delay the process. You can see the word delay in the batch status indicator. So now we just shut down the power supply and do the lockout takeout and check the pump. Okay, so we can inspect the pump. What is wrong with the pump? Yeah, you see the pump impeller is not turning freely and seems to be binding. Binding means hitting the cover, the impeller cover, the pump cover. That's why the pump is not able to turn fully in full force. That's why it take longer time to pump, cause a delay to the process. So we had to repair the pump. Then we run the process one more time. Now we are awaiting the pump to start. How we know the pump is start? You can look at the pump contactor. Push in, the button is pushing, the contactor button pushing, that means the pump is running. Yes, the pump is running. Now running on full load current of 2.3 ampere instead of overload current. So from what I see, the troubleshooting is done. Everything going smoothly. Okay, pass.